This is the teacher help video for Unit 7 study guide. So get you a piece of paper, work the problems along with me, and make sure you pause if you need to in between questions, because I'm going to try and go through this as fast as I can so it's not too long. So we're going to be using everything you learned in Unit 7. Get you ready for the Unit 7 test and the Unit 7 Illuminate assessment. All right, make sure you fill out the information. And let's start. Which of the following statements about angles is correct? A. Complementary angles can be supplementary only if the sum of their measure is 90 degrees. Hold on. Let's think about what we know here. Complementary angles are two or more angles who add up to equal 90. Supplementary angles are two or more angles that add up to equal 180. So they're not the same thing. They're completely different relationships. So that is incorrect. Supplementary have to equal 180, and they're talking 90 here. Let's go to B. Complementary angles can be supplementary only if the sum of their measures is 180. No, because complementary can only go up to 90 degrees. So not correct. C. Complementary angles can never be supplementary. Oh, we found our answer. Got to put the pin on for that to work. Sorry about that. There we go. And the last one says complementary angles are always supplementary. We know that's not true. Complementary equal 90, supplementary 180. Different relationships. All right, let's go to number 2. Which of the following statements about angles is correct? Vertical angles can never be supplementary. Well, let's talk about what we know about vertical angles. Vertical angles share a vertex. They're across from each other, and they're always equal or congruent, which is the geometry word for equal or equivalent. So that is, they could be supplementary. I could draw two perpendicular lines. I got a 90 here, and look, vertical, I've got a 90 degree here. They don't share a side, but they are across the vertex from each other. So that's not correct. Let's read the next one. Vertical angles can be supplementary only if each angle is 90 degrees. We just drew that. That's true. That one's 90, that one's 90. We add those two together, they give us 180 degrees. Remember, supplementary angles do not have to be on the same line. If they give you two angles that aren't sharing a side or adjacent or vertical even, and they ask you what they equal, you add them together. So these are vertical angles, and they're also supplementary because they're both 90 degrees, and together their sum is 180. So that's correct. We found the right answer. Here it says vertical angles can never be supplementary. We know that's not true. Wow, they put the same one twice. All right, and vertical angles can be supplementary only if the sum of their angles is 90. Well, that's not true either. Supplementary, the sum is 180. All right, let's move on. Number 3, adjacent angles can never be complementary. Let's talk about what adjacent angles are. Adjacent angles are two angles that share a vertex and share a side. There is no rule about how much they have to equal, but we definitely could have them be complementary. They share a vertex, they share a side. Those right there are adjacent angles that are complementary. So that is not correct. B, or that is not correct because we saw we can do it. Okay, B, adjacent angles can only be complementary if the sum of their angles is 180. Well, that 180 makes it wrong because complementary, the sum is 90. So that is not correct. C, adjacent angles are always complementary. Again, that's not correct. We've seen adjacent angles be supplementary. where they add together to equal 180, or adjacent angles could be any measurement that we decided we wanted them to be. See? Adjacent. So, not true. Okay? So, D. Adjacent angles can only be complementary if the sum of their angles is 90 degrees. That's true. So, if we have two adjacent angles and the sum is 90, then they're complementary. So, that is true. Boom. All right. Let's move on down. It says on number 4, which of the figures shown below is an accurately drawn and labeled triangle with two side lengths of 4 centimeters and a 45-degree angle? Well, let's go look at them. Remember, that means the two sides are the same. And I see here we've got two sides the same and a 45. That's a 90. Since these sides are the same, that means we have two angles the same, meaning this would be 45 too, because 45 plus 45 is 90, plus 90 more is 180. And remember, the angles in a triangle have to add up to equal 180 degrees. This one looks correct. I'm going to go ahead and mark it. Let's go look at the others. B. Well, everybody should see what's wrong with B right off the bat. Look what they labeled that, 45 degrees. That's not a 45-degree angle. We know that that mark means a right angle, and a right angle is 90 degrees. All right, let's move on here. They've got two sides that are labeled 4 and a 45, but look what they did wrong. They made the long side, or the hypotenuse, 4 centimeters. It's across from the 90-degree angle. It should be the longest side. So the two 4s, a 4 cannot be on that side. All right, on to D. Oh, they did it again. They labeled this mark that tells us it's a right angle. They labeled it 45 degrees. So nope. So it's A. We were right. All right, let's move on to question 5. Select all the conditions for which it's possible to construct a triangle. So we're going to go through these one at a time. And, select all means there's more than one. So we got to find them all. All right. The first one, a triangle with angle measures of 60 degrees, 80 degrees, and 80 degrees. So if they give you 3 angle measurements, we're going to add those up. Because remember, the sum of the angles in a triangle can't have to equal exactly 180 degrees. So 60 plus 80, 140. Plus 80 more. That's going to give me 220, and I went over 180. Can't make a triangle out of that. All right? So let's move to the second one. A triangle with side lengths of 4 centimeters, 5 centimeters, and 6 centimeters. Okay, when you have 3 sides, we use the triangle inequality theorem. And all that means is that we add the 2 shorter sides together and get the sum, and the sum of the 2 shorter sides needs to be bigger than the third side, okay? So let's see. 4 plus 5 equals 9. And 9 is bigger or greater than 6. So, yes, it makes a triangle. And that's how we check if we have 3 sides. I do short, short. I take the short side plus the short side, get my answer, then I compare it to my third side, my longest side. My number needs to be bigger or greater than the longest side to make a triangle. All right, let's go to the next one. A triangle with side lengths of 4 centimeters, 5 centimeters, and 15 centimeters. Well, again, short plus short, 4 plus 5 gives me 9. And it's 9 is supposed to be greater than the third side in order to make a triangle. Well, the third side's 15, and 9 is not greater than 15, so it does not make a triangle. All right, let's go to the fourth one. A triangle with side lengths of 4 centimeters, 5 centimeters, and a 50-degree angle. We definitely can make that, okay? We've got 2 sides and an angle. The angle is not huge. Remember, it can't be over 180 degrees, and it's got to leave room for 2 more angles. We certainly did. Here we go. All right, the next one. A triangle with angle measures of 30 degrees, 60 degrees, and a 3 centimeter side length. Again, this time we have 2 angles and a side. Well, you just have to make sure that the 2 angles they gave you don't go over 180 and they leave room for another angle. They do. We've got a short side length. They didn't give us something unreasonable. Even if they did, we could still draw. The biggest thing is your angles, okay? Can't have them equal like 179 or, you don't want it to be close to 180. You want to leave room for a third angle there, right? Can't go over 180 with all 3 angles. So we could definitely do this. We could make it. All right, we found them. Select all. All right, we're going to move on to the next one. Question 6. Use the diagram below and find the values of angle X and angle Y in degrees. All right, well, let's look at this first. See what we know. First thing I do is I look for vertical angles. And right here, X is right across or vertical to 35 degrees. So you already found X. X equals 35 degrees. Great job. That was easy. Now, we got to find Y. And we've got 2 Y's and a 35 on a 180-degree line. Remember, a straight line equals 180 degrees. So that means we have 2 Y's plus 35, and altogether that equals a whole line of 180. So my first step is to take away the 35-degree angle. And when we do that, we're left with our 2y angles, and that equals 145. We're not done. A lot of you miss this because you think you're done. You're not. You have 2y angles. They want to know how much each one is. So finish your equation. We're going to divide both of them by 2. We're going to divide by 2 to find out how much each y is. And y is going to equal, we're going to do 145. I'm going to do it the long way so you can see it. Divided by 2. 2 goes into 14 7 times. We got nothing left over. We bring down our 5. 2 goes into 5 2 times. And 2 times 2 is 4. It leaves us with 1. I'm going to go ahead and put a decimal here. Put a 0 and bring down my 0. Put my decimal straight up. And 2 goes into 10 5 times. And 2 times 5 is 10. So we're done. And there's our answer. Y equals 72.5 degrees. So make sure you have this written down. Let's go find the answer. X is 35. Y is 72.5. No. We got 35, but that's not correct. We got the right numbers, but they've got the wrong angles. Make sure you check close. And look at D. X is 35, Y is 72.5. So make sure you have the correct numbers and they're with the correct angle letters. Boom. All right. If the square pyramid shown is sliced parallel to the base and halfway up, which correctly describes the cross section? So parallel to the base. Here's your base. It's a square. We are going to draw a cross section parallel to the base. That means a cross. So anytime you do them across, they're going to match the base. And since this is a pyramid and goes up to a point, that means it's getting smaller, right? It's going to match your base shape, but it's getting smaller because as it goes up, you're going up to a point and it gets smaller. So let's see if we can find it. A triangle with a, no, a quadrilateral that's not a square, that's not true. A square smaller than the base of the pyramid. There it is. The last one says a square the same size as the base of the pyramid. That is not true in pyramids because as you go up, your pyramid goes to a point. So that means your cross-section gets smaller as you go up from the base. All right, number 8. Which below describes a unique polygon? Okay, a unique polygon has to be one that works, okay? But you have to have sides. They need to talk about sides in a polygon for it to be unique. So that's the important word there where it talks about unique. They need to talk about sides, and that has to be true. So the first one says a triangle with angles 30 degrees, 50 degrees, and 100 degrees. When we add that up, that equals 180, but it doesn't tell us anything about the sides. So no, it's not unique. We could have a bunch of different triangles that had a 30 degree, a 50 degree, and a 100 degree, and they wouldn't look the same. Okay, they could have side lengths of anything. Remember, angle measurements don't determine the size of your figure. I remind my class that the corner of your paper is a 90-degree angle, and so is the corner of the room, which is a lot bigger. The angle measurement does not determine the size of the shape. All right, let's go to B, a quadrilateral. Well, I'm stopping right there because if it's unique, it's got to have a better name. In other words, it needs to have the name like a triangle, a square, a rectangle. Not quadrilateral. Quadrilateral just means 4 sides. So I'm stopping. Even though it says each side is 5, it doesn't have the right name to be unique. A quadrilateral that has each side equal to 5 should be called a square. But they didn't use that word, so we're not picking it. All right, let's go on to C. A triangle with side lengths of 6 centimeters, 7 centimeters, and 8 centimeters. They gave us 3 sides. We're going to make sure it works. I do my short plus my short. I get 13. And 13 is bigger than the third side. There is a unique triangle. No matter what triangle I draw, if I draw it with the same side lengths of 6 centimeters, 7 centimeters, and 8 centimeters, it's going to be identical to a triangle somebody else draws with those measurements. We could flip it different directions, but it's still identical. All right, the last one, a triangle with side lengths of 4 centimeters, 5 centimeters, and a 50-degree angle. Even though we have 2 sides the same in one angle, we don't have the measurement of the third side, and there could be different measurements. I could draw one, you could draw one, and they might not have the same third side. So that's not unique. This is the only one that is a unique polygon. All right, let's move on. Number 9, calculate the volume of a triangular prism shown below. So they gave us a triangular prism. So first thing I need to do is remember my volume formula. Volume is equal to the area of the base, that's what the big B means, times the height. So the first thing we need to do is find our base. Any time you get a prism or a box, you look to see, do I have a shape that's other than a rectangle? I do, a triangle. That's its base. It does not have to sit on its base. It can sit on its side. So you got to look to see, do I have a shape that's other than a rectangle or square? And I do. Okay, so we're going to find the area of the triangle. Now, we got to have some facts here. Let's remember our facts. About rectangles, sides across from each other are the same. And that's important because when you're looking for the area of a triangle, you do the little b, base times height, divided by 2, or you can do 1/2 base times height. And to find base times height, you look for your 90. I found my 90. I've got my height, but my base is blank. Anytime it's blank, look across. There it is. If this side is 6, this side is 6 centimeters. Okay, so let's do the area of the triangle first and get the area of the base, which is our big B. So that's going to be 4 times 6 divided by 2. So that is 24 divided by 2. So that means the area of our base, or our big B, is equal to 12 centimeters squared. Remember, area is always square units, volume cubed units or cubic units. All right, so we have that number. Now all we need is the height. Now, here's where people miss this. I want you to remember that this is not sitting on its base. So imagine flipping this so it's sitting on the triangle. If we did that, this side would be straight up and down. So there it is. So when it's not sitting on its base, you're normally going to find the height at the bottom or top. But it's going to be connected to your base. Has to be connected to your base. All right. So that means we're going to do 12 centimeters squared times 10 centimeters. And when we do that, we get 120 cubic centimeters, which you can see it written out like cubic centimeters, or they can do it as centimeters to the third power. Means the same thing. All right, let's go find that answer. 240, no, 240. Notice they're trying to trick you by putting different units. This is volume. When you're doing volume, the units are always cubed to the third power. There it is, 120 centimeters to the third power cubic centimeters, because we're doing volume. Boom. All right, we got one more left. I'm going to go ahead and clear my screen real quick. All right, what is the surface area of the triangular prism shown below? Okay, we need the surface area. And remember, the surface area is the area of every single shape that makes up this prism. And then we add them all together. There are several different ways to do this. You can make a net of this. And if I was going to make a net, I would draw my bottom, what it's sitting on first. And then you'd have a triangle up here. And it doesn't have to look pretty or even like the shape. Rectangle there, a rectangle there. So you could do it that way, okay? And do your sides from there. 6 centimeters. We've got a 5 here. These are 10. Okay, I mean, it's whatever works for you, all right? 6 centimeters, 5 centimeters, 10 centimeters, 5 centimeters. All right, so from there, I forgot a little line to get my height of 4 centimeters. So you could use this, or the method that I use is I draw my shapes off to the side. I've got 2 triangles, probably because I'm not very good at drawing nets. All right, that are 4 and 6. So I'm going to find the area of the triangle first. Remember, area of a triangle is base times height divided by 2. So we already found that earlier. Remember, it was 4 times 6 divided by 2, and the area of one triangle, 1, was 12 centimeters squared. And we have 2 of them, 2 triangles, so the area of both triangles is 24 centimeters squared. All right, now I'm going to move over to my two sides of the box, and they are the same. So I have 2 rectangles that were 5 and 10. And 10 times 5, because remember, when you're getting the area of a rectangle is base times height or length times width. You find a corner, boom, and you find 2 sides. So 10 times 5, 50. Each of the side rectangles area is 50 centimeters squared. But we got 2 of them. 2 times 50. So the total area for the sides is 100 centimeters squared. And these were the sides. And we've got 1 rectangle left. The bottom. The bottom. And I go look at it, and I find myself this. And you could do it here. See? 10 and 6. And 10 times 6 is 60 centimeters squared. And we only have 1. Now, to find the surface area, we just add all that up. So we're going to add all three numbers together. 24 plus 60 plus 100. Bring down our 4. 2 plus 6 is 8. Bring down our 1. So the surface area is 184 centimeters squared, or square centimeters. That's the surface area. Remember, surface area covers the entire box, unless they ask you to leave a side out. But they didn't. So they wanted the surface area of the whole thing. And we found it. Let's go find the answer. 172? No. 182? Uh-oh. Looks like I had the wrong answer there, huh? Well, it's supposed to be 184 centimeters to the second power. And I can promise you that one will be there. So make sure you click 184 centimeters squared. And I'm going back to fix that little error I made on there. Made it too fast. So now you have the answers to all of your questions for the study guide. Good luck on the test and have a great day.